This part serves as a follow-up to my previous discussion and demonstration regarding how you can generate a proper orthographic three-view layout sketch from a known object, in this case an Elmer's glue bottle. So what I would like to do in this part is to follow up and teach you how to generate a perspective, two-point perspective sketch from this three-view orthographic layout that you've already done from the previous part. So this we will achieve by not only drawing in two-point perspective, what you've already learned with two-point perspective, but also utilizing what is usually called Boolean operations to essentially carve out this shape from basic primitive geometric forms like cylinders and bricks, which are essentially a variant of a cube. It's just a differently proportioned cube. So let's get started, and I will kind of take you step by step through how you can go from here to here. All right. So the way you start off is by first looking at generally the proportions of the front view. Now, the front view gives you the most information about its overall proportions, and these purple lines here will basically indicate how you can break down, any object into very basic rectilinear forms. In this case, our brick shape, which forms the main body. As you can see here, this is something I've already done, but I will actually show you again step by step how to get here. And then this top part looks like another brick shape, but it's actually just a cylinder viewed from the front. So cylinder is viewed from the front. In orthographic views, it typically look like rectangles. All right, so essentially just taking an object and trying to break it down into its most simple orthographic rectilinear forms or cylindrical forms, its primitive shapes. So let's see how we go from here to here. So basically, we know that the proportioning is based off of this thirds idea here. So what we can do, as you see here, is to start by basically drawing our main rectilinear body right here, okay? And we know that the body has essentially a proportion of 1 unit to 2 units tall, 1 unit wide to 2 units tall. So we'll start with edge on because we're drawing a two-point perspective sketch here. And we know that just like a cube, we need to throw some lines out to the left vanishing point. And in this case, what I'm doing is basically what I call estimated convergence. We know that there is a horizon line up here somewhere. It may not be actually physically this close, but I'll put one there just as a reminder. And then what we can do is estimate based on that 1 to 2 ratio, 1 to 2, so that looks about right. Okay. So in this process, there will be a little bit of guesstimation here. And then we can see that from the side view, this is about similar to half of this bottle from the front view here. Okay, so we can certainly do that. And the halfway point on this is about here. So now again, whenever we're laying out these construction lines, we do want to make sure that they are actually all vertical, especially as they relate to your distant horizon line here. Okay, so that still doesn't go away. We want to make sure we keep everything nice and straight where it needs to be. All right, so now what we can do is just basically use our estimated convergences toward those left and right vanishing points to complete this particular block representing the body right here. That's what we're really trying to draw in two-point perspective. Now what we'll have to do is to move on and construct this particular cylinder here. So as you know, cylinders are based around center axis. So we know that, for instance, with this bottle, that the center of this circle is basically centered right here, right down the middle. So the easiest way to find a center on any plane, rectilinear plane, is to essentially draw an X from its, it's basically draw diagonals from its corners. So now we found the true center, and what we can do is go ahead and extend up our center axis, because we know we'll need that to to construct this cylinder here. So this is what we can do. So what I usually like to do is start from the base upwards to construct a cylinder. And what I'm about to do here is an example of what's called additive Boolean techniques. All right, so you're essentially gluing or growing a cylinder from this surface right here, or you're gluing a cylinder to this surface. So in this case, we know from our orthographic earlier that the edges of this cylinder really are about halfway from center line. So this being center line right here. So I've done 2 dots, again being mindful of the convergences toward the right vanishing point. So what I have here now with true center, these 2 tangency points and these 2 tangency points right here, is the ability to basically construct an initial ellipse right here. Okay, so what this allows us to do now is to basically, because we know we're after a cylinder, is to go ahead and from tangency of these curved edges here, just project this the rest of this cylinder here. So we know that this cylinder is about 1/3 of the overall height of this, so we can kind of guesstimate about how tall this should be. So up here we can close off this cylinder by using our major-minor axis technique to just close it off. And we know that the degree or thinness of this ellipse gets thinner as it gets closer to the horizon line up here. Okay, so and then of course you'll notice that the degree is a little bit fatter as it goes further from the horizon line. So now we basically have our main blocks, primitives. Then what we'll need to do is just to start to carve away from it. So if you remember from the orthographic, we had these particular main lines here. Okay, so what we want to do is to replicate those main lines, and in fact what we can do is we can use major axes as a way to basically plot those same lines out. So we had looks like maybe 2 main lines here. So one for the collar and one for this particular part of the neck here and here, and then this last curve at the top, which basically ends right at the center of this ellipse right here. Okay, so let's go ahead and put in these ellipses. So we know that as we get further up toward the horizon line, the degrees of these ellipses are going to be a little bit they'll get a little bit thinner. Okay, but it's a gradual thing. We know that this next section here to here comes from a smaller ellipse that basically starts right on this larger ellipse right here. So we can basically eyeball that. All right, and we'll put in a little bit of a straight taper on the sides. Here I'm not going to draw the ellipse completely, I'll just draw half of it, and then the rest of it will be the tip right here. So here we have basically laid out and essentially carved away this particular form or this component of the cap. All right, so that being said, we really have just the rest of the body to do, and as you can see, the body is pretty straightforward. It's straight-sided on from both the side view and a front view. All right, so that means that our job is pretty easy. However, there is a slope that is inherent to the shoulder of this. So what we'll need to do is replicate that slope. So I just highlighted this particular line right here, center line across this top plane right here. What we'll use that as a gauge to see how far down that shoulder should go. And you can see I just dropped a dotted line down, and where that dotted line stops, I am going to do another dotted line here. And basically what this signifies is the amount that the shoulder has dropped from this point here to that point there. And so I'm just going to draw a center line down that way. What this gives me is a sort of a very clear target for me to hit when I draw that dropped shoulder down. So it's essentially like you're bending or curving an oval, which is essentially the cross section of this bottle. Okay, so we can kind of eyeball the other side. So now everything else is very straightforward. We just need to drop this side down, and we can drop that side down. However, we still need to figure out the bottom here. Now, this is a little bit tall because you can see right here, this is fairly long in comparison to the body. So what I'm going to do is I'm actually going to shorten this just slightly by actually shortening the block. All right, because you're in a construction stage, it's okay to do this. It's not a big deal. And what I'm going to do is I'm going to draw through like sort of what I call X-ray view, and I'm going to just mock up my oval base in the bottom here. Okay, so what this gives me is a visual representation of my glue bottle. So as you can see, I have essentially carved away a shape by using the cross sections provided by my top view from my orthographic view, by the front view of my orthographic, and to some extent to the side view, especially where this shoulder slopes down. You can kind of see how far down it dips. So here we are. We have essentially a three-dimensional representation of what is a two-dimensional orthographic sketch over here on the left. So that is what's called a Boolean operation, actually mostly subtractive Boolean operations to come to this final perspective view here. All right.